Chapter 4 Carbon and its Compound Introduction. All living and non-living components in the environment are carbon-based. Human body contains 18% of carbon and act as the basic building block of the cells present in human body. It is necessary for the cellular respiration of the various parts of human body. Carbon is basically an element and is of extensive importance and significance, both in its elemental form and in its combined form for the survival on Earth. 0.02% of carbon is present in bonding in carbon. A. Atomic number of carbon is 6. B. Electronic configuration has 2 electrons in K shell and 4 electrons in L shell. C. In order to attain the noble gas configuration, carbon should either gain 4 electrons or lose 4 electrons or can share its 4 electrons with some other element. D. Gain of 4 electrons to form octet, i.e. 8 electrons in C4 anion is difficult, because then a nucleus with 6 protons will have to hold extra 4 electrons. E. Loss of 4 electrons to attain duplet. I. Carbon attains the noble gas configuration by sharing its valence electrons with other atoms. Such mutual sharing of electrons between atoms to attain a stable, noble gas configuration is called covalent bonding. I. Atoms of other elements like hydrogen, oxygen, nitrogen, chlorine also show sharing of valence electrons. J. Depending on the number of electron pairs shared, covalent bond is of 3 types. Times single covalent bond. Single covalent bond is formed because of sharing of 2 electron. Properties of covalent bonds. Times covalently bonded molecules have low melting and boiling points. Times comparatively weaker intermolecular forces, unlike ionic compounds. Times these molecules are generally poor conductor of electricity since no charged particles are formed. 2 important properties which enable carbon to form enormously large number of compounds. I. Catenation is property of carbon atom to form bond with 2. Tetravalency, having a valency of 4, carbon atom is capable of bonding. W. Bonding in hydrogen. Times the atomic number of hydrogen is 1 and has only 1 electron in its K shell. Times this shell needs to either acquire or lose an electron to attain noble gas configuration of helium. Times due to this reason 2 hydrogen atoms share their outermost electrons, leading to the formation of a molecule of a hydrogen, H2. Times the shared pair of electrons between the hydrogen atoms constitutes a single bond between them and is also represented by a line between the 2 atoms. Bonding in oxygen. Times the atomic number of oxygen is 8 and has 6 electrons in its L shell. Times this shell needs to either acquire or lose electrons to attain noble gas configuration of neon. Times so each atom of oxygen shares 2 electrons with other atom of oxygen to attain the nearest noble gas configuration times the shared pair of electrons between the oxygen atoms constitutes a double bond between them and is also represented by two parallel lines between the two atoms as shown in config. Bonding in nitrogen times nitrogen has the atomic number 7 and has 5 electrons in its outermost shell times this shell needs to either acquire 3 electrons to attain noble gas configuration of neon times so each atom of nitrogen shares 3 electrons with other atom of nitrogen to attain the nearest noble gas configuration times the shared pair of electrons between the nitrogen atoms constitutes a triple bond between them and is also represented by 3 parallel lines between the two atoms as shown in the figure. Versatile nature of carbon times the versatile nature of carbon due to the presence of covalent bond enables it to form a large number of compounds. Carbon due to its property of catenation possesses a unique ability to form bonds with other atoms of carbon rise to large number of molecules and compounds having long chains of carbon, branched chains of carbon or carbon atoms arranged in rings and linked by single, double or triple bonds.